Hello everyone. Today I want us to look at this question on network analysis, and as you can see, we have activity preceded by, and then you have the duration. You have all the activities running from activity A all the way to activity E, and then we are asked to draw a network diagram. And part B of that question says we determine the critical path and the project duration. So for us to be able to draw a network diagram, we must first identify where this network diagram will start from. So in this case, we can be able to see that activity A, it doesn't have a predecessor. Same case to activity C, activity B, sorry. But activity C, for us to be able to start with activity C, activity A must have come to an end. For us to start activity D, activity B must have come to an end. For us to be able to start activity E, activity C and activity D must end together. So meaning activity C starts from where A ends, and activity D starts from activity B. So what we need to do for us to be able to draw the network diagram, we always start with the first node. And I want us to draw the network diagram. And a node looks like that. And I want to divide my node this way. I want us to have our node number 1 here. And this node, it has got two quadrants, the first quadrant or the upper quadrant and the lower quadrant. The upper quadrant, it represents the latest completion time, or the LCT, and then we have the lower quadrant. It is going to represent the earliest starting time of an activity. So having said that, let us proceed to drawing the network diagram. And I've said that any activity that does not have a predecessor should always start from node number 1. So this is going to be our node number 1. Our node number 1. And since because activity A and activity B ranks their predecessors, they must start from activity number 1. So this is activity A, and an activity is drawn with an arrow, or is indicated or represented by an arrow. And in this case, this is going to be our activity A, and this is going to be our activity B. I've said any activity that does not have a predecessor should always start from node number 1. So this is going to be activity A. So we go to node number 2, and this is going to be our activity B. It is going to end here so that we can be able to proceed to any other activity. So this is going to be our node number 3. Going down, we can be able to see that for us to be able to start activity C, activity A must have come to an end. And we need to move forward to look whether C, it is a predecessor of any other activity. So in this case, C, it is a predecessor of activity E. We usually look ahead in order to know the direction of a network. Before we draw activity E, activity C and D must have come to an end together. So activity C, it starts from activity A, or it starts where activity A comes to an end. And activity D starts where activity B comes to an end. So we want to draw activity C. And I've told you that activity C, it is starts from where activity A comes to an end. So this activity A, it has come to an end. Now we need to draw activity C. But for us to be able to know the direction of the network, we need to consider this activity E here, whose C is its predecessor. And I've told you that for us to be able to draw activity E, activity C and D must end together. So in this case, what you need to do, we need to have this clear picture in mind that assume this we want to draw activity E, meaning activity C and activity D, they must end together so that we can be able to get activity E. So this is a clear indication of where we are heading to. So here we have activity A, and I've told you that after activity A comes to an end, that's where activity C starts. So we need to draw activity C here, and then activity D starts where activity B comes to an end. So this activity B, it has come to an end. Now we need to have activity D starting from where B comes to an end. So we need to draw another node. So this is going to be our node number 4. And then, because I've told you that activity E, for us to be able to draw activity E, activity C and D must end together. And they have ended together in this node number 4. So meaning now we are going to get activity E, and then from there you draw our last node, which is node number 5. So these are our network diagram. So this is the network diagram. Now we need to proceed to the second part of this question now, which says determine the critical path and the project duration. So for us to be able to determine the critical path, so a critical path is always the longest path in a network diagram. We need to know that a critical path, it is always the longest path in a network diagram. And for us to be able to find the critical path, we must first find the earliest starting time or the forward pass. So in this case, what we need to do, we need to say this that the earliest starting time or the EST, it is equals to maximum over earliest starting time of the starting activity, you add the duration. So we are moving forward. So the earliest starting time, I want you to know this, the earliest starting time of the first node, which is this node number 1, it is always equal to 0. So I told you that a node, it has got 2 quadrants. The upper quadrant, it represents the latest completion time, whereas the lower quadrant represents the earliest starting time. So this is the earliest starting time of node number 1. And I've told you that the earliest starting time of the first node is always 0. So we need to write 0. And for us to be able to get or to obtain the earliest starting time of node number 2, according to the formula, we take the maximum over earliest starting time of the starting activity. So this is the earliest starting time of this starting activity. We add the duration. So in this case, we need to indicate we need to show the duration of all these activities. So activity A, I hope you can be able to see the duration is 5 days. Activity B, duration is 3 days. For activity C, duration is 10 days. For activity D, duration is 2 days. And the last one, activity E, the duration is 6 days. Now, let us proceed with our question. And I've said that the earliest starting timer is equals to the maximum of earliest starting time of the starting activity. You add the duration or the project duration. So for us to be able to get the earliest starting time of node number 2, we take the earliest starting time of this node number 1. Then we add the project duration. So this is 0 plus 5, it will give you 5. And then we have 0, you add 3, so that you can be able to get the earliest starting time of this node number 3. So 0 plus 3, it will give you 3. Now we need to proceed to node number 4. For us to be able to get the earliest starting time of node number 4, we can move in 2 directions. So the first route is moving from node number 2 going to node number 4, which is we can take the earliest starting time, which is 5. You add the project duration, which is 10. It will give us 15. And you can also use the other direction or the other route, which is you take the earliest starting time of node number 3, which is 3. You add the project duration, which is 2. It will give you 5. So according to our formula, I've said that the EST or the earliest starting time, you take the maximum of. So between this route, moving from node number 2 to node number 4, and moving from node number 3 to node number 4, which one is giving us the maximum? It is this one, moving from node number 2 to node number 4, because it is giving us 15. But moving from node number 3 to node number 4, it is giving us only 5. So we take the maximum of. So you take 5 plus 10, it will give you 15. So that's how we get the earliest starting time in case you find that 2 activities are ending together at a particular node. Now let us find the earliest starting time of node number 5. I've told you that for us to be able to get the earliest starting time, we take the earliest starting time of the starting activity. In this case, the starting activity is going to be this one. You add the duration, so 15 plus 6, it is going to give you 21. So that is the forward pass. Now we need to go back to find the latest completion time, which is also referred to as the backward pass. And for us to be able to find the backward pass, what we need to do, we're supposed to say this, that the latest completion timer, or LSCT, it is equal to minimum of latest completion time of the ending activity, then you less duration. Here we are doing the opposite. In the forward pass, we were taking the earliest starting time of the starting activity, and we add it to the project duration, so that you can be able to get the earliest starting time of the next activity. But in this case, for the latest completion time, we are taking the latest completion time of the ending activity, we less the project duration. So in this case, we are going to start with the last node, which is node number 5. And for us to be able to get the latest completion time in the last node, EST, or the earliest starting time, is always equal to the latest completion time. Meaning, if the earliest starting time of this node number 5 is 21, the latest completion time of this node number 5 must also be 21. Now we want to move backwards. So for us to be able to get the latest completion time for node number 4, we take the latest completion time of the ending activity, which is 21. You less 6, it will give you 21 minus 6. It's supposed to give you 15. Then we have we want to get the latest completion time for node number 2. So we can take 15 minus 10, it will give you 5. And then the latest completion time for node number 3, you take the latest completion time of the ending activity, which is 15. You less the project duration, which is 2, and it will give you 13. Now we are going to the last node, which is node number 1. And for us to be able to get the latest completion timer for this node number 1, we can move in 2 directions. Why? Because we can decide to move from node number 2 going to node number 1, or we can use node number 3, or we can start from node number 3 going to node number 1. So in case we move from node number 3, node number 2, we go to node number 1. We take the latest completion time of the ending activity. It is going to be 5. And then we raise the duration, which is 5, to give you 0. But once we decide to use the other route, we take 13, that is the latest completion time of the ending activity. We raise the project duration, which is 3. So 13 minus 3, it will give you 10. So because our formula says that the latest completion time, it is equal to the minimum of. So which one between these two is giving us the minimum value? So obviously it is this one, 5 minus 5, which gives us 0. So we take this one, 5 minus 5, now we get 0. So that is a complete network diagram. Now, because I told you, for us to be able to find the critical path, we must first find the earliest starting time and the latest completion time. And we have been able to get all of them. We have moved forward and backward, and we have been able to get the earliest starting time and the latest completion time. So critical path, it is whereby the earliest starting time is always equal to the latest completion time. So in this case, in node number 1, we can be able to see that the earliest starting time is 0 and the latest completion time is 0. Once we go to node number 3, the earliest starting time is 3, whereas the latest completion time is 13. But I've told you that the critical path, it is where the earliest starting time is always equal to the latest completion time. So 13 and 3, they are not equal. But 5 and 5, they are equal. So earliest starting time is 0, latest completion time is 0. That is equal. Once we go to node number 2, we have earliest starting time is 5 and latest completion time is 5. So that is one of the path that we are going to use. Going to node number 4, we can be able to see that node number 3, the earliest starting time is 3, but the latest completion time is 13. So we cannot move this way. Why? Because the earliest starting time and the latest completion time, they are not equal. And I've told you that critical path is where the earliest starting time must always be equal to the latest completion time. So we are not going to use this route because these two are not equal. So we have decided to use this route. Going to node number 4, we can be able to see that here we can be able to see that the earliest starting time is 15 and the latest completion time is 15. So they are equal. So this is another route. And then going to the last node, we can be able to see that the earliest starting time is 21 and the latest completion time is 21. So meaning the critical path in this case is going to be 1. It's going to be from node number 1. We go to node number 2. We go to node number 4, and the last one is node number 6. Because the earliest starting time and latest completion time for node number 1, they are equal. Earliest starting time and latest completion time for node number 2, they are equal. Earliest starting time for and latest completion time for node number 4, they are equal. And earliest starting time and latest completion time for node number 5, they are equal. So sorry, this is 5. This is 5. So that is the critical path. But the question says we determine. The question says determine the critical path, and we have been able to get the critical path as 1 to 2, 2 to 4, and 4 to 5. And the project duration. So project duration you pick from the critical path. So in this case, because from 1 to 2, from this node number 1 to node number 2, the project duration is from this node number 1 to this node number 2, the project duration is 5. So here we have 5. From node number 2 going to node number 4, node number 2 going to node number 4, we have a duration of 10 days. So you add 10. From node number 4 to node number 5, this node number 4, this node number 5, the project duration is 6. So once you add 5 plus 10 plus 6, it will give you 21 days. That's how you find the project duration.